Okay, 9.6 in the textbook is about drawing the Lewis-Dot formulas or Lewis-Dot structures. The process that you go through is obtain the skeleton structure, telling which elements the center atom and then which ones are the ones around it. Typically, the least electronegative element is on the outside and is the leftmost on the periodic table. So typically that's written first, except for in hydrogen. Second is to calculate the total number of valence electrons. 3 is to start adding the bonds or the skeleton structure. 4 is to put atoms around the electrons around the atoms around the central atom, so basically outside atoms. And then 5 is if you have any left over, then you distribute those electrons around the center atom. And the last step, which is not numbered because you don't have to always do it, but you want to check it, is if the central atom does not have 8 electrons, then you need to use multiple bonds to satisfy the octet rule. So only use a double or a triple bond if the inside atom does not see 8 electrons. One more time. Use double bonds or triple bonds if and only if the center atom does not see 8 electrons when you've given up all the electrons. Okay? Alright, so basically we're going to practice this. So write the formula, or the question is write the Lewis formula instead of Lewis formula. I mistyped that. Of phosphorus tribromide. Okay, so step 1 is obtain the skeleton structure. And this video is always in the wrong place. Obtain the skeleton structure. So phosphorus is the least electronegative, so it goes in the center, followed by, and so I basically put each bromine, and each bromine is going to connect to that phosphorus. So that's my skeleton structure. Step 2 is to calculate the total number of valence electrons. So we've been working with this all week. Phosphorus is, there's only one phosphorus atom in the structure, and it's in group 5A, so it has 5 valence electrons. Bromine, there are 3 of them, so that's where this 3 comes from. And then there are 7 valence electrons around each bromine, so that's 21. So the 5 plus the 21 gives me 26 electrons. So I have 26 electrons to work with to make this structure. Write the skeleton structure of the molecule or ion, so that means I'm drawing bonds. So every time I use a bond, I use up 2 electrons. So I added 6 to bond each bromine to the phosphorus. I used up 6 electrons, which is going to leave me 20 electrons. Alright, distribute the electrons around the outside atoms. Go down here. Okay, so this is the same structure I was with last time. Okay, and I had 20 electrons left. So I'm going to add 2, 4, 6, 8, 10, 12, 14, 16, 18. So the 20 minus the 18 leaves me 2 electrons. And so the next step is to distribute electrons around the central atom. So I have 2 more electrons. So those are going to go around the central atom. And so I've color coded. Okay, so this was, the red was in this step, and the blue was this step. Okay, and so I've used up all 20 of my electrons. If I count, I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26, 28. I did something wrong here. Alright, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I couldn't count the first time. But that's 26 electrons, which was my total number of valence electrons. So the last step is to make sure that my center atom, phosphorus, sees 8. Okay, and so I've got 2, 4, 6, and 8. So I'm done with the structure. Okay, you can also draw these as being dashes. I did the first one with being dots. Okay, so we go on to problem 9.66, which is draw the, well, I copied and pasted the question. So misspelled Lewis again. Formula for the following. Now this one is an ion instead of a molecule. Okay, it's cyanide ion actually. Okay, so step 1 is obtain the skeletal structure. There's only 2 atoms, so there's really not a center atom. It's just carbon and nitrogen. Calculate the total number of valence electrons. Okay, so what we did last time. There's 1 carbon atom. Each carbon has 4 valence electrons, so there's 4. There's 1 nitrogen atom, and each nitrogen has 5, so that's 5. I have a negative charge on this, so therefore it has one more electron because of that negative charge. So the 4 plus 5 plus 1 gives me 10 valence electrons total. That's what I have to work with. Write the skeleton structure, so I put a bond in, and I use up 2 electrons then, so now I have 10 minus 2 to give me 8. I want all this one to go in the same. Distribute the electrons around the outside atoms. Okay, it doesn't really matter which one I start with as far as carbon or nitrogen, but technically nitrogen has more electronegative, so I'm going to start there. So again, I'm using dashes instead of the dots, but it's the same thing. Every time I add a dash, it represents 2 electrons. So 2, 4, 4, 6, and 8. And I'm out of electrons because I only had 8 more to go. So I check. Does both atoms see 8 electrons? Well, nitrogen does because it has these 6, which are the lone pair. It has these 2, which is the bonding pair. But carbon only sees the 2, 4 electrons. So in this case, they do not all see the same, or do not both see 8 electrons. So now I need to fix that. How do I do so? Well, I share more electrons. So nitrogen's got to give up 4 more electrons because of the fact that I need 8 minus 4 is 4. Okay, but I don't want to move them over to the carbon because then it's not sharing, and nitrogen would then not see 8. I want it so both atoms see 8. So what's going to happen is that if there are less than 8 around the center atom, then I use multiple bonds to satisfy the octet rule. So I'm going to move this one into a bond and that one into the bond. And basically at this point I need to redraw the structure because I didn't want to change the structure up here, so I did that here. So here's my structure up here with the red being my initial bond, the blue being the electrons around the outside atom, but then the last step of needing to make sure that each atom saw 8, I added my triple bond. So this has a triple bond. What I just realized I did not do, and I don't think I can do this, is that this is an ion. So just like when we have an ion with the Lewis symbol, is I really should have put this one in a bracket with a negative sign outside to show the fact it was an ion. Okay, so is there any questions about that? Because that is the section. I highly suggest you go back and do, that was 6.2, so 6.1, 6.3, and 6.5, 61, 63, and 65 in the book to see if you know how to do this. And then there will be a quiz. This will be due by Wednesday of next week. There will be a quiz on D2L that will ask questions from all 3, including what did you understand least about these videos in each section.